Welcome to the Walton Pi. Today we're going to go through a test problem that might show up on a calculus test in either AP Calculus or maybe Calculus 1 at a university. So before we get started, if you're not subscribed, please consider doing so because it actually does help me out quite a bit to be able to keep making these videos. Okay, now how would we approach this limit? Well, what we can do is we can break this up using a couple limit laws, and we can say that this is equal to the limit as x goes to minus infinity of 4 cosine 7 over x minus the limit as x goes to minus infinity of e to the x sine x. Now let's deal with this first one first, I guess. So how would we approach the limit as x goes to minus infinity of 4 cosine of 7 over x? Well, as x goes to infinity, this inside piece is going to 0. So what we're dealing with is really just 4 cosine of 0. Well, cosine of 0, that's going to be 1, and so that means we are left with this thing is equal to 4. But then we still have this other limit we have to figure out what to do with. So how can we deal with the limit as x goes to minus infinity of e to the x sine x? Well, let's just look at each piece and see what happens. E to the x, e to the negative infinity, remember the graph of e to the x is this graph, so as we're going this way, we're heading off towards 0. Now, so that means that e to the x is going to 0, but sine of x, that's going between negative 1 and 1, and it's not really going to either one, so we don't know exactly what sine of x is going to, which means we can't just plug it in and say, oh, this is going to 0. We think it's going to 0, but we have to show that's going to be the case. And the way that we're going to be doing this is by using the squeeze theorem. So the squeeze theorem is going to need a function that's always bigger than e to the x sine x and a function that's always smaller than e to the x sine x. Well, what we can do is we can start by saying, well, sine of x, that's always between 1 and negative 1. And if I multiply everything by e to the x, that's not changing any of the signs because e to the x is always positive. So that means that that is going to be a chain of a set of inequalities that's going to still be true. Now I can look at the limit of each of these as x goes to minus infinity. Oops, I put the negative in the wrong spot. Let me fix that real quick. Minus infinity of e to the x with a negative there. Well, what this is, that's just equal to 0. So then we are left with the limit as x goes to minus infinity of what we actually care about, e to the x sine x. And then we need to figure out what is e to the x doing. Well, the limit as x goes to minus infinity of just e to the x, that's a 0. So that means that this limit has to be going to 0. So we are left with just a 4 minus 0, or this is going to 4. And this is how you would show that on a test. This is what the work you would need to do, and you'd need to reference the squeeze theorem to get full credit. Thanks so much for watching. If this was helpful, please consider subscribing, and if you really liked it, please like the video. If you have other videos you'd like me to go over, please leave those in the comment section down below, and I hope you all have a great rest of your day, and good luck with all of your math.